Question 29, part A. So this is like implicit differentiation again, right? And always look for a product. There's usually product in this question. So you got your product there. So your u is equal to x, your v is equal to tan 2y. So du dx is equal to 1. Yeah, and differentiate that. Do v dx then, well, differentiate this. So tan becomes sec squared, if you remember. So it becomes sec squared 2y. Yeah, but because it's a function of a function, it's tan of 2y, so you get sec squared 2y, but you're going to times it then by the derivative in here, which is 2, okay? And of course, don't forget to plonk a dy dx on the end as well, because you differentiate in respect to x, but you do it with respect to y first, don't you? And then you put a dy dx on the end using the chain rule. So tan 2y becomes sec squared 2y, you've got to times it by 2, don't forget. Derivative in there, so this becomes 2 sec squared 2y dy dx. Okay, so then when it comes to differentiating this, then that's 3x squared. That's 2y dy dx. This then is what we've got over here, the product rule. So v du dx, so tan 2y plus u dv dx, so plus 2x sec squared 2y dy dx. And of course then that's nicely then 8 just becomes 0, doesn't it, when you differentiate that. Okay, so then factorize the dy dx, take all the other things over the other side, and then of course you take this down and divide, okay, and you got your dy dx done in terms of x and y. Okay, so that will get you the marks there. If you wanted to, you could go a step further. You could factorize out on the top there. You could take a -1 out, couldn't you? So you could do this, okay? And then you could take a 2 out on the bottom, okay? But you should get full marks for this to get into this situation here, okay? But if they ask you to show this, then you can see how I've done that. I've taken out a minus on the top, taken out a 2 here on the bottom. Okay, part B, right, parametric. Starting a new sheet of paper here. So we've got here, find dy dt, it says, right? So we've got x, let's write these down first of all, 3t plus t squared. So when we have a parametric question, we usually write them both down like this, don't we? Okay. Now they're not asking for dy dx, notice, okay? Here they're just asking for dy dt, so we just need to find this, derivative of this. Of course, the derivative of this is a quotient, isn't it? So you've got to use the quotient rule, okay? So sometimes you can get tricky, some situations like that where it's not so easy to work out dy dt, okay? You know, dx dt, that's easy, isn't it? They're not asking for it. Maybe we'll need it later on, but that's, I can just do it because it's so easy. Okay, with dy dt, you've got to use the quotient rule. So the quotient rule, u will equal the top term, v will equal the bottom term, du dt will equal 4, dv dt will equal 2. Okay, so then quotient rule, then you've got to crisscross these. Okay, so to get dy dt then, it'll be v du dt, take away then u dv dt, all over v squared, which is this here, squared, right? So when we've gone over quotient rules in previous questions, always keep the bottom like this, because this is as simple as you can get. The top though, you can expand it out, sort it out, because this can be written a lot simpler. So we get 12 plus 8t minus 2 minus 8t. You can see then, it's quite nice because they will cancel. So you end up having 10 over 3 plus 2t all squared. Okay, so there's your dy dt there. So quite a bit of work that time, but that's the way it was because it was a quotient. So question part 2 then, it says find dy dx, simplify your answer as much as possible. So dy dx, well, remember with dy dx, you want dy dt times dt dx using the chain rule. Now dy dt we just worked out. dt dx, remember I worked that out at the top. dt dx then will be 1 over that. Yeah, you just the reciprocal of it. So that would be 1 over 3 plus 2t. Okay, and then this is simplify as much as possible. Wow, you could see there you've got 3 plus 2t occurring there, the bracket. Okay, so you can put them together, cubed. Okay, job done.